I'm going to give a rough draft of a talk that I'll be giving in a couple weeks at ApacheCon. And so it's a rough draft for a couple of reasons. One, because it's not done, and two, because I didn't want all those poor people that are paying to go to ApacheCon to just be able to watch a video and not go to ApacheCon. No, I'm just kidding. Okay, so the agenda looks something like this. I'm going to talk a little bit about distributed systems very, very briefly. Then I'm kind of introduce where Mesos plays a role with building distributed systems. I'm going to talk a lot about the API to building your own distributed system on Apache Mesos, mostly from the scheduler perspective. I'm going to give some examples, look at some real code, and then kind of do a little bit of a deeper dive again in some of those API components, and kind of finally wrap up and show how you might be able to use some of the other bits of Mesos, the web UI and the CLI, when it comes to the operational experience of running a distributed system on Mesos. Okay, so right, how many people have seen this before? Just one person, great. So this was actually not my quote. This is somebody's paper at ACM. It's a great paper if you haven't read it. Yeah, I think there's something really interesting, which a lot of people these days, when they sit down to write their next application is really a distributed system. And when I talk about a distributed system here, I'm talking about a very particular kind of distributed system. My PhD advisor would be really mad if I kind of lumped all distributed systems into one bucket. I'm really talking about distributed systems that more or less have a coordinator, one or maybe some other failover coordinators, and then have a bunch of workers where they're actually trying to run their computations. And when you think about what a distributed system has to do, it has to do a ton of stuff. There's a lot of things it has to do. But sort of the meat, the core of the distributed system is really in the coordinator, where the coordinator is trying to decide things like what processes or tasks does it actually want to run, in a distributed way usually, what it wants to do when things fail. At least the distributed systems that I like are the ones that are fault tolerant and actually take that into account. And finally, in what ways might it be able to optimize its performance? That is, whether or not it can be elastic or it can be smarter about the way that it actually schedules its computations. And when that's kind of the core of maybe building a distributed system, there's a lot of other stuff you have to do. But the core is really sort of coordinating execution. That's like the meat of most distributed systems that get built. And that's kind of where Mesos really plays a role. Now, this talk was not called Building Distributed Systems on Apache Mesos. It was called Building Frameworks on Apache Mesos. And that's because, more or less, we think of a framework as a distributed system. And so if you kind of look at a distributed system anatomy like we looked at, and instead you took a step back and say, well, what is in the framework world? Well, we don't call it a coordinator, and we don't call them workers. We call it a scheduler, and we call what you actually end up running tasks and or executors, and we'll talk a little bit more about that in the future. Now, why do we do that? Because when you think about that core part of a distributed system, I think I've said core a lot in this talk, so notes to self for next talk, say core less, okay. The execution coordination, really what that is that scheduling. So that's kind of why what we call in a framework is the scheduler. And where Mesos really plays a role is it comes in and it says, all right, well, let's let the scheduler or the coordinator focus specifically on the important bits, and let's get the other stuff out of the way, right? So it provides this level of indirection. It says, all right, the scheduler will communicate directly with the Mesos master, and the Mesos master will be responsible for doing all that other stuff with the slaves, all the distribution, all the monitoring of tasks, so forth and so on. So that level of indirection really provides a bunch of wins. The first win is, well, next time you could go to build your distributed system, you don't have to re-implement all that stuff that pretty much every distributed system re-implements. Right? You could just leverage this layer to do what you want to do, and there's a bunch of that stuff that you might want to do. And then on top of that, now you get to run multiple distributed systems, or you could, in theory, on the same cluster of machines, on the same resources, and you can start to do smart things where you drive up resource utilization, you oversubscribe, you do all sorts of other stuff, which saves your company lots of money in terms of CapEx and OpEx. Okay, so Mesos, that level of indirection is really where it plays a role in these distributed systems. All right, so for those of you that don't actually know what Mesos is, that's all we're going to talk about for Mesos for this talk. In my defense, the ApacheCon talk will have there'll be a previous Mesos talk given by some nice gentlemen here, Nicholas and Adam, where they're going to be giving a lot more background. And this talk's going to kind of be going into more of the details. Okay, so I'm going to move on, and I'm going to talk about the actual API, what it would look like if you wanted to build your own framework on Mesos. And I'm mostly just going to focus on the scheduler API. Okay, so looking again at that picture of sort of a framework communicating directly with Mesos versus actually working with all the machines, the API really consists of two primitives, which I'm calling here calls and events. Okay? So calls are basically messages that a framework will send to Mesos, and events are things that a framework might receive. So the semantics here is these calls and events, they're very low level, they're unreliable, it's effectively one-way message passing. The model that you can think of if you're going to be building a framework against Mesos is really an actor-like programming model, except the messages are well-typed, and they're known, and you can expect certain things to show up. So there's a really important reason why the API for Mesos was designed this way, and one of the reasons why it's not just a request-response interface, other than the fact that this is a distributed system, failures occur, you've got to deal with all those types of things, is because in our cases, we actually want to generate events even when no request has occurred. So events you can think of them as really this stream of stuff that's always coming. So it's not just request-response, there's stuff that you might always be getting. Okay? Okay, so calls on the scheduler side, I've sort of broken them up into components. And the core calls are things like register, re-register, unregister. And by the way, just so we're totally clear here, this is a fairly low-level-y talk on Mesos. I hope that's okay. All right. So the core lifecycle management calls are register, re-register, unregister. For resource allocation, there's calls around requesting resources, declining resources that have been allocated to you, reviving some of those declines. You can actually decline resources and not get allocated those resources in the future unless you say later, hey, actually, I'd like some of those resources back. And then finally, things around task management, things like being able to launch a task, kill a task, acknowledge the status of a task, or reconcile the status of the task if for whatever reason you no longer know what state the task is in. Okay, and on the event side, so those are things that a framework scheduler is sending to Mesos. And on the event side, there are things like finding out that you're registered, finding out that you've been re-registered, receiving resource offers. These are resource allocations. Having resource allocations be rescinded from you, and then finally finding out an update about some task. Okay? And I'm going to kind of go into a few more concrete examples of when this stuff would actually occur right now. So the way that this would work would basically is a scheduler, when it first wants to actually, say, run some computations, it starts and it sends a register call to a Mesos master, which would naturally respond via an event that says, OK, you're registered. Now, at the point that a framework actually gets registered, resource allocations, what we call in Mesos offers, will be made to the scheduler. And if a scheduler wants, it could make some specific resource requests to help inform Mesos about what resources it would likely want to use. So I've grayed out the request because it's actually optional. An offer as an event will show up to the scheduler after Mesos has actually allocated resources for the framework. The scheduler can then use those resources to decide what tasks it might want to run. Once it's decided what tasks it might want to run, it can launch tasks. And at some later point in time, it might receive more allocation, more resource offers. And at some point in time, it'll also receive an update about that task, which is the state of that task after it's been launched somewhere in the cluster. Okay, so now that's very much the low-level API. I'm going to move on to what this would look like if you were to actually try to implement something like this today yourself. Okay, so Mesos has some APIs in C++, Java, and Python in its source tree. And there's also APIs that are out of the tree that you can find probably by some Google searches. For Go, Go is actually written by Nicholas. I don't know the state of the Ruby ones. I don't know if anybody here does. Nicholas would know the state of the Erlang ones. It works, okay. Haskell was announced recently, and I think we tweeted about it today. But those are all out of tree. Those aren't maintained by us, but I think that they're probably great. And if any of you are the authors of those things, we'd love to get those in tree if it makes sense. Okay, so these are the APIs that exist currently in Mesos, but they're more what I would call the medium-level APIs. We're actually currently working right now on exposing the low-level APIs. So the examples that I've previously shown are really the low-level APIs. But what you can work with right now in Mesos is sort of this slightly higher level. And let me explain what I mean by that. So rather than actually getting a handle on events, what you get via the scheduler, what you do is you implement, this is Java, by the way, sorry. There's a bunch of different interfaces. We're going to do Java because that's probably the lowest common denominator in the room. Okay, rather than receiving events, what you do instead is you implement a callback interface. And that interface passes to you the information associated with the event. So to receive a registered event, you effectively implement the registered callback. When you receive a re-registered event, you'd implement the re-registered callback, so forth and so on. Okay? So that's how you receive events. Now to make calls, you use what's called a scheduler driver. Okay? And the scheduler driver has a bunch of methods on it, things like start. Now, this is a totally awesome trivia question. Why is it called start instead of register?
Red API.
What's that?
Red API.
No.
Because it also does re-registers?
There is also re-register, but no. Who said that? Because register is a keyword in C++. Ah, OK. All right. So if we wanted it to be consistent across all the languages, we went with start. OK, so but again, this is a medium-level API because it actually does a lot of the re-registration under the covers, things like launch, so forth and so on. So that's how you do calls. Now the way these two things compose together is effectively you implement your scheduler, and then you use a scheduler driver, and you give to the scheduler driver your scheduler, along with some other information about your framework, which I'm going to talk about in a little bit. And the scheduler driver is responsible for doing all the communication with Mesos and effectively taking your calls and sending them to Mesos and grabbing events and calling the callbacks on the scheduler themselves. Okay? So this is kind of how all the pieces fit together. So if you were to go and try to do this on your own, these are the things you'd be implementing, and this is some of the code that you would want to actually do. Okay, so now I want to actually make a deeper dive into some of the specific events and calls, kind of the core ones that you would actually want to use if you were to build a distributed system on Mesos. Okay, so a key point here is that we use protocol buffers effectively to give us an extensible data structure that we can share across multiple languages and across the network. So 99% of the types that you'd actually use if you were to build your own framework on Mesos, you'll actually be working with the protocol buffers. OK. All right, so registration. So registration, it's a call. You try and register, or you call start in the case of the medium-level API. And the core protocol buffer data structure that you work with is something called framework info. And I'm going to talk about these fields in framework info as a way of describing actually how some of the components all end up working in Mesos. All right, so we're just going to dive right in. All right, so this is kind of, if you look at this picture, we're in the register call, and now we can look at this protocol buffer struct. So one of the first fields in there is user. User is effectively responsible for the user that this framework will use when it runs tasks somewhere on some box in the data center. For example, root. If you want your framework to be able to run as root, you could say, I'm root here. OK. The name is the human readable identifier. So in the example that oh, wait. Yeah. OK. Is it Twitter Scheduler or Aurora? It's still sort of Twitter Scheduler, right? Okay, so if you were to bring up Aurora and you were to go to the Mesos web UI, you would see that the name of the framework that was running is called Twitter Scheduler. This is the human readable identifier that we use on the web UI. Then there's a machine readable identifier. And that machine readable identifier is what we use to basically tag each instance of a framework that's running. Now, this is an optional field, which means that it doesn't need to be set for a register call. But if you're trying to re-register, it does need to be set. Now, why might you want to be re-registering? If you're failing over. So failover, what is this failover stuff you're talking about? Well, Mesos was designed to allow a framework's scheduler to actually fail over. If it fails, another one can come up and take place of the previous one that was running. Clearly, you can imagine that this is super important for high availability at a place like Twitter where we can't have any downtime. So in that case, when you're actually re-registering, you'd previously know your framework ID so that you can reconnect. Okay. All right. So now, should all frameworks fail over? Not necessarily. It doesn't necessarily make sense that all frameworks fail over. If you don't want to fail over, that is to say, if your scheduler were to die, you just want all your tasks to get cleaned up, you can set the failover timeout to 0, which is to say when your scheduler goes away, all tasks will also be cleaned up. However, if you'd like to fail over, you can, when you explicitly register the first time, you can set the failover timeout to some number, and then Mesos will continue to run all of your tasks until another instance of your scheduler reconnects and fails over. So this is interesting because for most people that I've talked to that have been building distributed systems on Mesos, they never want like 5 seconds or 10 seconds. They want like forever or don't fail over. So kind of an unfortunate aspect here, but you could set it to the max double or you could set it to 0. Okay. So finally, checkpoint. So what's the checkpoint flag all about? Well, when you actually launch your tasks on the slave, it's possible that the slave itself might fail. And if you enable checkpointing, it makes it be the case that your tasks continue to run, such that when a slave shows back up, it can reconnect to the task just as though nothing had happened. So this is a pretty valuable feature as well, and it lets us, or the operators of a Mesos cluster, actually upgrade Mesos itself while the tasks that had already previously been launched continue to run. So as a framework, you can specify that you want this functionality by setting the checkpoint flag. Okay, role. So in clusters that are running with multiple potential organizations, you might want to pre-reserve resources to different organizations. This is how you specify what role you might want to get resources allocated from. And hostname is the local hostname. If you don't set it, we'll set it for you. Okay. So that's sort of registration side of thing. Now on the offers side of things, so offers is this event when you receive resource allocations from a Mesos master. And I'm kind of going to jump through these things. So offers very similar. It has an ID, which is a machine readable identifier for the offer. You use that later when launching tasks. I'm going to skip a few here. The slave ID is also a machine readable identifier for the slave that these resources are coming from. You might want to know that because you're running other tasks there. The resources, these are the actual resources that have been allocated to you that are available for you to run some things. And that's all I'm going to talk about for offer. And then finally, launch. So when you launch, the protocol buffer that you care about is something called task info. You'll be constructing one of these task infos to actually launch your task. It's a call. And the name, again, a human readable identifier. The task ID is generated by you, the framework. You can think of it kind of like your PID of the task that's running, or your TID. It must be unique across all the tasks that you have running. The resources are the actual resources that this task is consuming. That's going to be important when it actually comes to isolating the task. And then finally, you have an option when you launch a task to either use an executor or to just give a command. And this is probably the most nuanced part of launching a task in Mesos, so I'm going to talk about it in a little bit of detail. So when you launch a task with a command, effectively what that means is that the task makes its way all the way to a Mesos slave, and the Mesos slave, for better or for worse, just launches it. It's a task, it's got a command. You can think of it basically doing an sh space -c space whatever the command is. Okay? In certain circumstances, that's exactly what you want, but in other circumstances, you want more control over how that task is actually being launched. So if you'd like more control, and if you think about the very beginning of the talk where I talked about sort of the workers sometimes will run multiple tasks when it comes to a distributed system. If you'd like more control, and you can run multiple tasks. If you'd like more control, you can use an executor instead. And the way that looks is that when you give a task that has a very particular executor, instead of launching the task, an executor is launched. So this level of indirection is launched instead, this executor, and the task is actually handed to the executor, and the executor decides how it actually wants to run the task. So in this case, the executor can say, oh, okay, I'm going to go ahead and I'm going to fork exec the task. The nice thing here is you can give multiple tasks to the same executor. So you can imagine, depending on the type of distributed system that you're giving, that could be advantageous. And in fact, tasks at this level are just completely opaque blobs to Mesos. So you can realize that task in whatever way you want, including just spawning some threads inside the executor or the worker. You don't have to fork exec some processes. It's just an opaque blob that we're actually giving to you. OK, and again, if you use an executor, if you launch a task with an executor on a particular slave, this doesn't mean that you can't run more tasks later on that slave without an executor. So you can mix and match however you please. OK, so the reason why this is interesting, though, is because one of the core tenets of Mesos is to provide isolation of the computations that are running. And the containers that we basically put around the things that are running are effectively the executor tree or the individual task. So if you just run a task with a command, we just put a container around that task. But if you run an executor and you pass multiple tasks to it later, the container is actually around that executor and whatever other tasks we've sort of plugged in there. And the nice thing about that is the container itself will grow and shrink based on, and when I say grow and shrink, I mean in terms of resource constraints, based on the amount of tasks you've actually put in there. So you can get this really nice fine-grained resource containment on an individual slave as well. OK, so I'm going to finish up now by just really quickly looking at the web UI and the CLI, because if you were to go home today and you were trying to build some of this stuff, these would be the tools that you'd want to use to help your life out. OK, and so basically, whoops. So I've just got a Mesos cluster running here on my laptop. There's nothing really interesting. There were some previously terminated frameworks that I'd run. What we're going to do is I'm going to launch another framework in here that is in the, whoops. OK. So if we're actually to download Mesos today, that there's some example frameworks. There's one called Long-Lived Framework, and we're going to go ahead and run that. And it registered with the Mesos master. Actually, let me actually restart all this stuff. I have a new IP, I think. Let me try this again. OK. This is just me bringing up. OK. So this is the Mesos master, and now you can see it's starting to run some tasks. So the nice thing about the web UI here is that if, for example, your task were to fail, you could quickly dive in and find out more about that task. Whoops. In particular, you could look at that task standard error, standard out. Standard just has arbitrary stuff, and standard out is just showing what tasks it's actually running. Okay. There's also a CLI for Mesos, where you can do similar things, but I think I'm going to cut it there because, yeah. Okay, so that's an overview of how you could actually build your own distributed system directly on top of Apache Mesos, and I'm happy to take some questions. So the question is it possible to send custom messages from an executor back to a framework? So the answer is yes, it is. There's a call in both directions, actually. You can send a message from a scheduler to an executor, or you can send a message from an executor to a scheduler. So there's a call that's effectively called send framework message. And on the executor side, it's send executor message. And they're unreliable. Those messages are unreliable, but they work for most things that people are trying to do. It's interesting, Kronos, the Kronos framework used that feature, and the reason why that's interesting is because Kronos is this distributed system that actually never opened a network socket. So it used the Mesos API, and it used that messaging feature to pretty much do everything that it needed to do without ever actually doing any network programming. And that's kind of what I mean about this higher level abstraction when it comes to building these distributed systems and being able to leverage that layer. Not that networking programming is bad, it's just if you don't have to do it, it's nice. So that's a great question. So we recently went through, oh, yep, okay. So the question was, what's the current state of external containerization with Mesos? So we recently went through a rather large refactor when it came to the isolation, and we now have basically two interfaces. One interface called Containerizer, which is a great name, and the other one called Isolator. And you can implement your own containerizers and basically start a Mesos slave with whatever containerizer you want. It's completely pluggable. And so your containerizer could do all sorts of things. It could launch virtual machines. It could use Docker. It could use LXC directly. It could do whatever you want. Now, if you use the default Mesos containerizer, you can also plug in and play different isolators. So there's a CPU isolator for the Mesos containerizer. There's a memory isolator. These use control groups. There'll be future ones for network isolation. And the plan here is that we just really want to be able to provide as many of these different isolators as possible. So based on people's environments, they can say, oh, yep, I would like to use that isolator because I'm running GPUs, and somebody has written the GPU isolator, and that's a resource that can get allocated, so forth and so on. But it's also, if you don't want to use the Mesos default containerizer, you can also write completely your own containerizer as well. That's the state, and you can start writing isolators today. Okay, the question was, non-standard resources. How can I do something with non-standard resources? For example, things that involve IOPS. Can I do some of that stuff today? So the way that Mesos works is when you actually start a Mesos slave, you can specify whatever resources you want, and you can give each of the resources a type. And there's more or less 3 types. There's a scalar type, which is a double. There's a set type, so a resource that has a finite number of things that you can take out of the set. And then there's a ranges type. And the ranges type is more or less just syntactic sugar for a set of integers. And the reason why that exists is because you can imagine one useful set resource being ports, but rather than sending around 65,000, a set of 65,000 things, it's nicer if I can send around a range of 0 to 65,000, right? So, so those are the 3 core abstractions, and it's not saying we couldn't have more. But if you can fit your resource into one of those 3 things, then you can specify that when you start up a slave, and Mesos will do all the accounting for you. So if you bring up a Mesos slave and you say that on this box I have a resource called IPs, and it's a set of 5 things, and say those are the public IPs that only certain people could be allocated, those will become a resource that can be consumed, and if a task consumes it, there'll be 1 less IP in the set. You could do the same thing with GPUs. Now, they won't be isolated unless you were to also then go write an isolator specifically for that resource name. And when a containerizer comes up, it looks at the resources that have been specified on the command line, and it looks at whatever isolators you gave it, and it just matches them. And so if you've got an isolator for GPUs, it will use that, whatever that means, when it tries to launch a task, and make sure that that task is isolated properly for that resource. So that again is where hopefully that if there's this very specific resource that you would like to use or isolate, you could write an isolator and contribute it back. Although you have to write in C++, although you knew the register answer, so you must write C++. Okay. So the question is, do we support role-based quotas to limit the resources? So yes, the role that I briefly mentioned in framework info is when a framework registers, you can also set when you bring up a Mesos cluster that certain resources should be reserved for certain roles, and then those resources will not be allocated to these frameworks. A lot of the work that we're doing now and in the future is to do smarter things around that allocation. But today, yeah, if you specify the reservations as such that these resources belong to this role and this is a framework from a different role, it won't be allocated those resources. One of the other things that we'll do here is we're actually going to be making this not role but roles. So frameworks can be allocated resources across multiple roles. So in certain circumstances, frameworks act as meta frameworks. They run for multiple different roles. Aurora is a good example of that. So the question is the term role is also being mapped to user IDs. In Mesos and Aurora, yes, that is an overloaded term.
So they're two distinct concepts?
They're two distinct concepts. Yes, that's unfortunate. The question was, do we plan to support asynchronous status updates in the lower level API? That was the question, right? Yeah. So the update was one of the, let's see, this guy right here. Update was one of the events that you can receive from Mesos. The way the medium level API currently works is you get one update at a time, which is incredibly expensive if you want to do any sort of persistence around that update. So with the lower level API, you'll be able to get a batch of updates, which means you can do things much more efficiently. Awesome question. OK. So Brian asked, what does the wire protocol of this look like? And are there plans to have native library? Wait, I went the wrong way, didn't I? Are there plans to have native libraries for the languages that we show here? So right now, while there is APIs in C++, Java, and Python, and all the other ones as well, they use the native lib Mesos to do a lot of work. And one of the main reasons why they do that is because that's implementing the actual wire protocol under the covers. So what is the wire protocol? The wire protocol of this is HTTP, which is great. So the plan is yes. We do plan to expose that wire protocol even more so. And ultimately, that will lead to people being able to write a native library. And there's not a ton of work that is needed to do that, but the biggest work is actually exposing the lower level API. And that's why that's one of the big pushes right now, to actually expose the lower level API. So once the lower level API gets exposed, then people can start writing completely native libraries. They'll just be implementing the transport themselves, but they can use any old HTTP library to do that. Great question. OK, so the question is there currently a way to interrupt a task? So you can kill the framework. But if you want to interrupt a very specific task, the answer is no. And that's also one of the issues that we'll be tackling right now. So I don't remember the JIRA ticket number, but there's a JIRA ticket out there, and we're going to be working on that right away. So the question is do we do continuous deployment of Mesos and Aurora? We don't do continuous deployment of Mesos. We stage Mesos in a cluster, and then we roll it out to other clusters after that. And Aurora is more or less the same way. Yeah. Although I believe that there are some people that do continuous deployment, and I think it's worked. We're very, very careful about all of our updates, about each version that's released, having some sort of upgrade path. And that's, again, because we don't want to have any downtime of our Mesos clusters. We want to be able to roll individual boxes to bring up the new releases without having to bring an entire cluster down at any point in time. So it's not continuous integration, continuous deployment per se, but we also don't require that entire Mesos clusters be shut down in order to upgrade Mesos to the latest version. And I don't think we'll ever do that. And by I don't think, I mean we'll never do that. I mean, if we, it's unlikely we're ever going to do that. I mean, maybe we'll. I mean, yeah. I'll just leave it at that. Okay, so the question is deploying Mesos in POPs, and what it might look like in terms of having multiple Mesos masters versus multiple Mesos clusters. So it's an interesting question. I think that I don't know that the latency issues would be too bad, depending on the type of task you're running. If you're trying to run tasks that are going to run for a very long time, the latencies will be dwarfed by the amount of time the task is running or anything else. So it's probably not a big deal. If you would run the masters themselves in a POP, it would be advisable to run masters in different POPs. So if you do lose one POP, things can keep running. I do know of some people that have run Mesos across AWS regions, where they've basically put the masters and Zookeeper in one region, but they've actually run some slaves in other regions, and they've tagged those slaves in those other regions with the attribute of that region, and then they've used constraint-based matching in things like Aurora and Marathon to effectively say run this task where it has unique region attributes. And we haven't heard anything from them about issues around latency issues or any of that kind of stuff. I mean, of course, if one of the regions fails, all the tasks are going to continue to run if the region with the master fails, all the tasks are going to continue to run in the other region, but you won't be able to schedule anything else. Yeah, so it's HTTP, and the low-level API is message passing effectively. So the sockets can go away and come back, and that doesn't mean anything. So if the socket dies, bring up another HTTP connection, post another message. Okay, let's cut it right there. Thanks so much for staying so late. I think there's still more pizza. Dave probably has more things to say.
Let's make sure that we thank Ben for great topics.
Yeah.